Hey, how's it going again? Sean Tech here, and I'm here to talk a little bit about good hand soldering techniques. And this is just in general because some of the students of the degree that I teach, we've been getting a lot of job requests, and the big hot in-demand item right now is hand soldering and hand solder technicians. That's like something that a lot of companies have just stated, we're in short supply. And there are some really good do's and don'ts to follow when doing any type of hand soldering work that I kind of wanted to go over with here in a quick kind of an impromptu video, if you will. Probably one of the most important ones, and this is in particular important if you're doing really any form of soldering, but I would say surface mount soldering or soldering of any chip components, and that's electrostatic discharge, ESD, and we want to mitigate static shocking of any kind to any of the stuff that we're really kind of working with. So what we want to make sure that we do when we do anything with soldering is to wear ESD mitigation equipment. And that usually comes in the form of like one of three things. Probably one of the more common ones that I've seen are these ESD wrist straps, right? So these ESD wrist straps that actually wear around your wrist like this, and they sort of you want it to be, you don't want it to necessarily choke you so that your blood pressure is no longer going here, but you don't necessarily want it to be completely loose. Actually, loose is probably worse because this thing does need to make a little bit of some pressure contact. You can see, like, I can still kind of stretch mine out like that there, and it's still kind of working. Then I connect it up to the wire that is connected to an ESD station. In the case for me, it's right behind my hot air rework station. It's where it's located at. This is always something you kind of want to periodically test and even ask about sometimes. It's one of those things to where it's like you just sort of assume it's connected. Normally you test yourself in advance to make sure that you are connected up to ground, but in the case of this, I mean, I may not necessarily know from my home station here, but this is one of those things always better to question. You also may have at some point ESD protection gloves, all right? And these actually have, if you look at the front of it right there, the ESD logo that's on the front of it. And this is basically there to help prevent me transferring any form of static shock down into the circuit board that I may be working with down over here. The third thing, which I don't think I've got one here, are the shoe straps or the boot straps. They actually go on the inside of or on the bottom of your shoe, but more importantly, you want it to make contact somewhere with the part of your foot that is stepping on the ground inside of your shoe. So this is like basically, you want to make sure that you are stepping on it with your sock. So the part of the boot strap that has a little gray carbon strip, you want that to actually go down and inside of your shoe so that it is on the bottom of your sock while connecting the actual the ESD connection part, the strap part of it around like the heel or in some cases the toe of the shoe. So, but always one part does always go on the inside of the shoe. If you will. So ESD prevention, always a big plus. The second thing when doing any kind of hand soldering based work is to check your tools. For large through-hole based components, you want a large soldering iron tip. For smaller based components, you want not so large of a soldering iron tip. And an excellent example of this would be kind of what I'm about to show on the screen here. Here's an example of something of a tip that I would use on a larger style tip, whereas the one that I'm going to do a little demonstration in front of right now, see this tip right here, is much, much smaller, much, much more fine. So overall soldering, what soldering's like, the primary way that it works is that heat is transferred from the hot iron tip into the part that you are trying to solder. You want it to heat up. You want the part to heat up to the point where solder will melt and basically fuse with the part. It's not just about melting the solder, although some parts with surface mount parts, they're so small that it basically, you know, it's just going to happen anyway. But for larger parts, for larger through-hole based parts, you may need to hold the soldering iron down to the tip for a long, long time in order to get it to the point where it heats up. Otherwise, you'll produce cold solder joints and solder joints which are basically doomed to failure at some point, mechanical failure more than anything. They may electronically work, but they're not going to work entirely in the long run with it. The tip is very, very important, not to mention a nice shiny tip. You can see that the tip of my soldering iron in this image right here is nice and shiny. It's a nice shiny tip. The shinier the tip, the better heat will conduct down through the tip and onto the soldering iron. If it's a dull tip, like a kind of a black corroded looking tip or a rusted tip, it's usually a bad sign. It means that the tip needs to be cleaned, more or less. And cleaning is done using something called tip cleaner. It's a little kind of a jar that looks like this here. I'll do a demonstration. With the soldering iron hot, I take the tip cleaner, and on the inside I've got something that I've actually already kind of used. I'm going to put it on the inside. Mine's currently set to about 610 degrees Fahrenheit, and you can see that this is actually going down inside of a tinning solution, as well as some cleaning solution, some fluxing agent as well. And when I brush off my tip, it is nice, and I don't know if you can see that very well on there, but it is nice and shiny, which is what you want. You want to have a nice shiny tip. That's like above and all foremost. That's really is what you want, I think, the most out of doing soldering, because otherwise it's not going to transfer heat correctly. Rust doesn't let heat conduct through it very well. It acts as more of a thermal barrier or a thermal impedance. And if you can't heat up the part you're trying to solder to, well, you're going to be in some trouble with it. All right? Let's demonstrate for the last part of this video right here. Let's just demonstrate what it means to actually do a soldering of a component down. I'm going to solder R7. Okay. There, R7. This is one of our practice boards out of the university here. I'm going to grab a good pair of tweezers. Always make sure you have a good pair of tweezers. And I have a chip component here that is a green chip resistor. Notice that there are numbers on one side, and if I flip the chip component over, it is the white ceramic part, and we don't want to we definitely don't want to solder to that, so we want to make sure that the numbers for a chip resistor or any chip component are up on top, while also making sure to observe polarity. Some components like resistors and some capacitors, it doesn't matter which way you put it on, but other components like diodes, LEDs, chip components like integrated circuits, transistors, that kind of stuff, it matters which way you put it on. And some capacitors too. Some capacitors are electrolytic and polarized, and if you put them on in the wrong way, you might permanently destroy them. So you want to always make sure that you observe the correct polarity when working with these things. So now I'm going to solder this chip component onto position R7 there, and I'm going to use this stuff right here called fluxing agent. Flux, if it's surface mount, flux is your friend. Flux is like the secret sauce to doing surface mount. And if your company isn't providing some form of a fluxing agent, they're making things really hard on you. They're making things a lot harder than what it actually is, all truth be told. So what I'm going to do is I'm going to spread some of this fluxing agent onto both of the pads, all right? And I'm going to demonstrate this from the point of view of a right-handed person. I am right-handed. This is my right hand here. And I'm going to use a soldering iron in my right hand and some solder wire, I'm trying to make sure I'm still staying on camera and everything like that, in my left hand. And I'm going to come down and I am going to tin the left pad. And tinning means to take the soldering iron, make sure I'm still on the screen there. Hello, I'll stay on the screen. Thank you very much. All right, I'm going to come down, I'm going to touch this, activate the flux. Activating the flux means to basically heat it up to the point where it begins to dissolve any kind of skin oils or rusts or anything like that. Now the way that I do this now from this point here is, I mean, if you can, use a pair of tweezers, but I have actually tinned the left hand pad, so I'm going to switch the soldering iron to my left hand, while with my right hand I take a chip resistor, if you will, here, and I'm going to move it into place. So I'm going to wet the surface of this. I'm going to watch as the solder stays on the chip, hold it into place. Big rookie mistake is to tin both pads at the same time. Unless you're using a hot iron, if you're doing it with just a regular soldering iron, don't tin both pads. That's going to make things harder as well as messier. What's that? You might have something that's got a pillowed type of joint where the resistor is sticking up off the board. You don't want that. You want the resistor to more or less, or any chip component, to be as flush with the board as possible. Let me kind of make a little bit of an attempt to show this. Notice how the chip component is more or less, sorry about that, is more or less just sitting on top of the board. There is a minimum gap between the actual board and the chip component. And that's so we don't trap things underneath the chip component or anything like that a little bit later on. Last one I'm going to do is I'm actually going to turn the board just a little bit here, reorientate myself with the soldering iron in my right hand and the solder wire in my left hand. And I'm using I'm actually using a lead-based wire. Let me do, just for demonstration purposes, let me use a lead-free wire next. The difference between lead and lead-free, very much so. I'm going to just kind of retin my tip again with a lead-free based stuff. The difference is between a lead and a lead-free joint. Lead is very, very shiny when it comes out correct, or very, very dull gray when it does not come out correct. That's the primary difference. Whereas lead-free sort of always looks dull gray, no matter how you look at it. It will always have that kind of a dull gray-like finish here, and I'm hoping I'll be able to kind of show that to you here just a little bit. But the other major difference is that some products, say for instance something that's made by lead-based solder, forms a better solder joint, and it's overall easier to work with because it has a lower melting point. You don't have to turn the soldering iron up quite so high in temperature to get it to melt. But it's more difficult to make a joint, so therefore a lot of folks that want very, very good, they want joints that are reliable, and so they won't use lead-free based at all. A lot of military applications I've seen are kind of like that. So I'm going to now come down, and I'm going to use a larger than normal amount of lead-free based solder, just so that I can show a picture, more or less show a picture of kind of what it looks like. Right now it looks very shiny, alright, but as soon as I take that away, look at that dull gray look. See how it looks kind of like, almost like it's matte, like it's a matte wall finish, more or less is kind of what it looks like there. I don't know if you can see that. So on the left hand side of R7, like the bottom left hand side, that is a lead-free based joint. Or excuse me, that's a lead-based joint, and the other one is a lead-free based joint. What I'm going to do here is I'm actually going to take some isopropyl alcohol, some cleaning solvent, and it's never a good idea to leave flux on the board. There we go. It's never a good idea to leave flux on the board, so you always want to make sure that you clean all of the flux off once you are done making the solder joint. Can you tell with that? It's a little, probably maybe a little bit easier to tell kind of with what that looks like there. But now, I mean, like through the microscope, I can definitely see it. They almost look like they're more or less the same bit here. And that's probably because I used the same soldering iron tip for both of them. Don't ever do that either. So make sure that the tips stay separate from one another while you're working with them. But anyway, just some helpful tips. Hopefully that gives you an idea. Just because there's been so many job requests lately for this here, and sometimes every little trick in the book counts towards, when you're needing to solder something down as large as this chip resistor that I've got, or something even smaller than that. So hopefully you've learned something new with this here, and pass this on to everyone else. And if you do get one of those jobs that we've been posting, let us know. All right, we'll see you around on the next one. See you later. Bye-bye.